AP Psychology students. I gotta get to the right spot. I was doing psychology before. AP Psychology. All right. AP Psychology students. We are closing all of these weeks because we're not working on these weeks. We are not working on week 8. We are done with week 9. We are on week 10. So in week 10, you are going to turn in your dream journal that you've been working on. All right, so let's look at this real quick here. Let's just look at the assignment together. You've been collecting dreams, and now you're going to work on part 2 of this. All right, and it's an analysis. Some people like to go through and label the questions and answer each one. That's absolutely fine, but you don't have to answer all the questions for each dream. You're kind of putting it all together. All right. So you're trying to say, are your dreams bizarre or mundane? And then maybe say, example, in dream 1, it was this, in dream 2. You could also kind of write an analysis that answers all 14 of these just kind of together, because you're kind of going back and forth between answering questions. It's completely up to you on how you do your analysis of your dreams. All right, so that is that part. And then the rest of the this work, you're going to be working on, really starting in on the College Board's Unit 2, right? You finished in this week the progress check and the assessment. If there is something that you want to go over again, or you didn't really understand after seeing the answers, please ask me. I'm very happy to help go over questions. There was some of the comments in the survey I sent over this fall break were that I use other people's resources and I don't make all my own. And that's because I'd really rather focus my attention on what each student wants than trying to recreate things that have been created by others. So you'll notice wherever I can, I do use other people's materials, and I try to put everything together so that it's useful to you. All right, let's go. So you can see these assignments shouldn't take too long. Just 2 kind of big ideas. This is a big idea concept map, basics of cognition. This should be something that you can do relatively quickly. If you'll see today, there's this video. I'm going to go over this advertising discussion, and the cognition map is written all for Monday. That's because I really just want you to get the big idea of what cognition is in this, and then you're going to spend time in each of the areas again. Same thing when you get to the end of the week with memory. This is an introduction to memory concept map, so you can see how all the different parts of memory are going to work together. And just as a preview, in week 11, you're going to get to start to see all of it working out. So let's jump to the slides I have here. My jokes are because it's Halloween, right? So this might sting a little, but your depth perception should improve almost immediately, right? We need both of our eyes to see depth. And what's freaking us out here is that we found a correlation between owning cats and being struck by lightning, right? If you remember, I put this here because you reviewed all of your Unit 0. I hope you see how much Unit 0 fits into all of the unit materials after you did the progress check. Remember, correlation doesn't mean causation, but it would be very scary if there was such a strong correlation between owning cats and being struck by lightning. All right, what are we going to do in the rest of this video? I'm going to help you see the big picture of cognition. We're going to kind of get you interested in some little facts and falsehoods. Hopefully this tests what you know about perception, but also just get you interested in some of the things you're going to learn. And then you're going to work on a discussion about advertising. And I have one of my favorite videos, one of my children's most favorite videos. Anyways, we already previewed the assignment. So let's just, my little image here shows us that we finished sensation, which is showing you how this visual information is coming to your brain. And we're moving towards perception, because if you're looking this way, you see ABC, because our brain puts together this visual information is a B. And if you look 12, 13, 14, if you're looking at numbers, your brain interprets that as a 13. So we can see how much the context matters in interpreting the visual information. Okay, cognition, huge term. If we thought about cognition maybe just in layman's terms, not as a psychological term, we might just think of it another way of thinking, right? If I say cognition, it might make you think of thinking, and that's kind of a good way to remember it, but it's not just thinking. The College Board threw perception in here because we are thinking, right? So we're going to split sensation and perception, and we're going to talk about how we put together, how we use these things to put together what we see, not in terms of the physical stimulus, but in terms of how we label it and talk about it. Cognition, also memory falls into cognition, decision making falls into cognition, problem solving falls into cognition, and the College Board in its latest revision took intelligence, which used to fit in with personality, and also put it here with cognition. And so I have intelligence as its whole other slide, because when we look at intelligence, we need to look at the theories of intelligence, which I completely hate that multiple intelligence is still taught as a theory. There's no good evidence for it, but the College Board hasn't removed it, so it's still here. And then we're going to also talk about psychometrics. That's how we know whether what we're measuring is very accurate or reliable. We're going to look at IQ tests. We're going to look at some special topics around intelligence. How does all of this relate to what's the College Board sections? You can see 2.1 through 2.8 are the College Board sections, and we're doing perception and beginning of memory in week 10. We're doing problem solving and the rest of memory in week 11, and we have intelligence in week 12, and the progress check practice test and the unit assessment in week 13. It gets us to almost Christmas break. All right, so let's do a little fact or falsehood, right? True or false? True or false? Most infants will crawl off the edge of a counter or table because they haven't yet learned to perceive depth. True or false? Motion provides cues for depth perception. True or false? Two objects that have the exact same color will be perceived as being the same color regardless of how much light is shining on them. True or false? It is an illusion that the moon looks up to 50% larger when near the horizon than when it is in the sky. True or false? People who are born blind with limited sight cannot visually recognize some objects later in life if their vision is restored. So I know I read that fast. If you need to, pause the video and pick true or false. You don't need to look up anything. Just based on your experiences, what do you think? And then resume the video when you're ready. First, I'm going to share the answers, and then we're going to talk about each one. Or I might kind of talk about each one as I go. So most infants will learn to crawl off a counter or table because they haven't yet learned to perceive depth. They really had some cool experiments with this. It was called the visual cliff, or officially the Gibson and Walkes visual cliff. And there's a piece of glass here, so that can't be perceived. And before a baby is able to crawl, so they're kind of maybe scooching around a little bit, sitting or rolling, right? Think of a baby as laying on their side, rolling over. They do not perceive depth very well, and they will fall off of this. But it's very interesting that the ability to crawl is timed up perfectly with the ability to perceive depth, and they won't crawl to their mother. They see that they see there's depth here and they won't go. But before they're able to perceive depth, because they have the same pattern, this all looks the same to babies. So that's why number 1 is false. Number 2, motion provides cues for depth perception. I hope you said true, because we all know whether something is coming towards us or moving away from us based on how big or small it is, right? So that happens. All right, this one's a little bit trickier. Two objects that have the exact same color will be perceived as being the same color regardless of how much light is shining on them. And there was an interesting graphic here, right? This dot looks significantly brighter. This one looks darker, right? And this looks somewhat in between. So based on how much light, the way we perceive it changes. But if we remove all the context, they are exactly the same color, right? So that is pretty cool. So the color depends on the context, right? How much light is there. 4, it is an illusion that the moon looks up 50% larger when near the horizon, right? My daughter and I take hikes often in the summertime when the moon is just coming up, and it's a whole conversation that the moon, that the earth is what is moving, right? That it's spinning. And this is also, the context makes it look different. There's one of the coolest, right? It's called the Ames window, right? That she looks bigger over here than over here, and we're gonna see why that is. If you're an artist, you'd be using many of these principles in your artwork.
Does what we see correspond to what's really out there? Or does our brain construct its own version of reality, one that does not always match up with the physical universe? Check me out, for example. I am the same size here as I am over here, but over here I look much larger. No, it's not a cheap video trick, it's a trick on your brain. Here's what you're seeing. The me over here is indeed projecting a smaller image onto your retina, the region of light detecting cells at the back of your eye. All else being equal, smaller images mean smaller things. Here, I'm in no danger of hitting my head on the ceiling. But over here, I am ducking. Ceilings are useful visual landmarks for judging size. Of course, you're making these size estimates based on the assumption that this room is ordinary and box-shaped. You assume the back wall is perpendicular to the line of sight, so the two versions of me are the same distance away. You're also assuming that the floor and ceiling are level and parallel. But as you probably guessed, this isn't the case, and the room isn't box-shaped at all. It's trapezoidal. The back left corner of the room is much farther away than the right. Since I'm farther away over here, my image is smaller, although I'm definitely not. The ceiling cue is also misleading. The floor actually slants upward and the ceiling downward from left to right, making my head much closer to the ceiling when I'm over here. Why couldn't you see these things and adjust your size estimates? The room's features have been cleverly distorted to be consistent with a rectangular shape. The checkerboard pattern on the floor gets finer grained toward the right, so that the same number of pattern elements fit in a shorter distance. The windows are resized and shaped to match the trapezoidal back wall. Your narrow angle of view from the front of the room blocks the cues that would reveal the room's true shape. And of course, we easily believe in a box shape because that's the shape rooms normally are. This clever setup is called the Ames illusion. American ophthalmologist Adelbert Ames Jr. devised it in 1934 and built a physical example the following year. For Scientific American's Instant Egghead, I'm Ingrid Wickelgren.
So I hope you found that interesting, right? So we can easily see that the moon looks 50% larger only because of the context around where we see it. All right, and last one, people who are born blind or limited sight cannot visually recognize some objects later in life. If their vision is restored, that is also true. And the people who studied this were called, their names are Hubel and Wiesel. They studied it with cats, and they took these cats, and for one set of cats, they basically couldn't see horizontal surfaces, and another set of kittens couldn't see vertical surfaces. And they basically block this visual information out during what's called the critical period, when their brain would be taking that information from the retina and sort of processing it or making sense of it. And when they got rid of limiting that, they never recovered. So the cats who couldn't see vertical things were always running into things, and the cats who couldn't see horizontal surfaces could never jump up onto surfaces because they didn't really know they were there. And so we see critical periods very much with hearing, with sight, and also degree with language, what sounds we're able to hear in different languages. We start to get rid of the ability to hear all sounds already by 6 months, and then we start to limit. It's more called a sensitive period than a critical period, is that we lose the ability to learn grammar from about the age of 8 through puberty. And if we start to learn a language after puberty, we will probably never, right? No matter how hard I try, my kids are going to make fun of how I say words in Hungarian. All right, so last thing to do, and I'll just quickly go over it, and then you'll work on it on your own. You don't need to stop the video because I'm going to stop the video, but you're going to go to the course page, and we have this discussion here called advertising. And your initial posting is going to rate yourself between 1 and 10, 1 being advertising has no effect on you, and 10 is advertising is very effective on you, and write why you think this. So just be honest, right? What do you think? Then watch this video, and then come back to your initial posting and re-rate yourself and explain if the video made you think differently about how advertising affects you. All right, so if you have any questions this week, I'm here to help you. Have a very good week. Thank you very much for your attention.